Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about problems of related rates. And basically, this has something to do with computing the rate of change of one quantity by using the rate of change of another quantity. Now, let's see what I mean by that. Basically, I think it can be simplified using this analogy of having to find out about x. You want to find out about x, but then you are using y in order to find out about x. Now, why are we using y? Because y might be in certain circumstances, the value of it is already there. It is already available. The information of y is there. So we're just going to use y in order to find x. Now, in another circumstances, it could be that y is easier to be computed. It is easier to be calculated. And that's why we are using y in order to get the value of x. Now, as an example, imagine you are pumping air into a balloon, and by doing that, of course, both the volume and the radius will increase with respect to time. Now, I hope that you can see the rates of increase here are related to each other, but maybe in that circumstance, it is easier to measure the rate of increase of volume compared to the rate of increase of a radius. So basically, this is just a simple example that illustrates or explains about why we use y in order to find x. Okay. Now let's look at a proper example here where you have a water tank that is in the shape of inverted circular cone with base radius 2 meter and height 4 meter. If water is being pumped into a tank at a rate of 2 meter cubic per minute, find the rate of which water level is rising when the water is 3 meter deep. Now, I think when you have this word problem, it is always a good idea to try and visualize the problem by sketching or drawing a simple diagram. So first of all, maybe we can start off by imagining how this inverted circular cone may look like. Now, this is the water tank. Water tank has this shape, inverted circular cone, maybe something like this. Okay, that looks all right. Now, we're going to take out all the relevant information here. So we know that the radius here is 2 meter. So this is r is equal to 2. And once you try and take out the information, try and write it in mathematical expression so that it's easier to play around later. So next, height is 4 meters. So this is the height. So now I'm going to write down here. So r is 2, height is 4 in meters. Now, if water is being pumped into a tank at a rate of 2 meter cubic per minute, so this is actually the rate of a volume, because when water is being pumped into that tank, so water is going to fill up into the tank. That means you are measuring the volume here. So you will get the volume of a water. So the rate of a change in volume. So this is the change of volume with respect to time. And volume, maybe we can say that V represents the volume of water in a tank. So now this one is dv dt, because you're talking about rate, so that means you're talking about the derivative. So this is dv dt is equal to 2 meter cubic per minute. Next, find the rate of which water level is rising. So you can imagine when the water is being pumped into this tank, the water will be increased, go on and increase. And so this is about the change of h with respect to time. So the question is asking you to find what is dh dt, the change of height with respect to time. So this is what the question is asking you to find. And given that the height is now 3 meter deep, okay, the water is now 3 meter deep. Now before we can answer all this question, we need to be able to come up with a formula of volume, because volume of a water has something to do with H, and that is our starting point. Okay, so now we know that if you have a circular cone, the volume of that will be, volume is 1/3 pi r square times h. So this is the volume of a circular cone. And we have a problem here because v here depends on r and h. Okay, v here depends on r and h. And r is the radius. The radius of the water, the volume here. So the radius here depends on time t. Height is also depending on time, which is t. The unit is minute. Okay, so therefore we need to simplify this formula so that there is only one variable involved here instead of two. So we are going to try and simplify and write down r in terms of h. Okay, so now we know that if we consider the ratio of r over h, okay, we just considering this, r over h will be equal to, what is r? R is 2 meter. What is h? H is 4 meters. So r over h, the ratio of that is equal to 2/4. This is something that we can get based on the information given here. Okay, based on this information and this information. So therefore I can express r in terms of h. So therefore r will be 2/4 is 1/2 times h. So times h. So now I'm going to use this and substitute this into this formula here. So what I have next is I will have 1/3 pi 1/2 times h squared times h. Now by doing this, I get rid of r, okay, because we don't need to find r actually, because the question is asking to find about h, okay, which is the height, dh dt, the rate of which water level is rising. So now we can simplify this right hand side, so it will look like 1/3 times pi 1/4 h squared times h, and you can write down in terms of 1/12 pi h cubed. So this is the equation that we will be using. This is the formula for volume. Now we can see that v now depends on h, and based on this I can actually find dv dh. What is dv dh? Okay, now I need to be able to link dv dh, dh dt that you want to find, and dv dt. So how do we link these three expression here? So one way of doing it, or the way of doing it, is just by saying that dv dt is equal to dv dh times dh dt. So this is how we can link up the three expression here. We have dv dh, dh dt, dv dt. Now if you look at this formula that we have here, if you differentiate this with respect to h, then we need to consider dh dt, because h is actually a function inside that. So this is just like the chain rule, the idea of chain rule. So the idea of chain rule, so this one is the idea of chain rule where you have this is the outer function. You differentiate that first, and then you differentiate the inside of that function, which is h. H is a function, so when you differentiate that, you will get dh dt. Okay. Now, some students they might get confused about how can we rearrange this part. Some might just say that, oh, okay, can I write it in terms of, I don't know, maybe dv dh equals to dh dt times dv dt. I mean, just some random arrangement, or maybe something else, I don't know, but this is wrong. Now I'm going to tell you the informal way of making sure that this is the correct mathematical expression. Now the informal way of doing that is, when you look at this, you can sort of think it like this, but although it doesn't work like this, you can think as if this can be cancelled out. This all this dh and dh can be cancelled out, so you are left with dv dt. So the left hand side is sorry, the right hand side is the same as the left hand side. Now if somebody else is doing this expression, now there is nothing that can be cancelled out, and you can see that right hand side here is not equal to left hand side, so definitely this is wrong. That is informal way of looking at things, although in reality you actually cannot cancel all this. This doesn't work like this. This is not something to be cancelled out. But if you just want to check whether your expression here makes sense, you can actually think of it like that. You can maybe, because this is dh, this is dh, you can cancel that, so you are left with dv dt. So right hand side is similar to the left hand side. Well, that's one way of looking at things if you're like clueless on how to construct or to link together the three components here. Okay, okay, so I'm just going to write down again this thing. Okay, so here we have dv dt, dh, and dh. Okay, so now dv dt is already given, which is equal to 2. So I'm just going to substitute that. So this is 2. dv dh, I'm going to differentiate this with respect to h. Okay, so this will be 1/12 pi 3h square. So this is what I get if I differentiate that with respect to h. And then h is a function, like I said. If you differentiate that, you will just get dh dt. So just leave it as it is, dh dt. Next, I will have 2 3/12 pi h square dh dt. And since you want to know what is dh dt, that can become the subject. So dh dt will be 24 over 3 pi h square. And what is h? H at this time is equal to 3, so we can substitute that. So you will get 24 3 pi times 9, so this is 24 over 24 divided with 3, so this will be 8. This will be cancelled, so you will get 8/9 pi. Okay, so that's the answer. So this is the rate of which water level is rising. So the value is positive, that means it is increasing. The water level is increasing with respect to time. Okay. All right, that's all. Thank you very much for watching.